Example number 4 on the power rule. As we will look to differentiate this equation, we want to take each of these denominators and bring them up so that we can look at the actual powers. And so my first step is to write this as a one-liner. 2x to the negative third, because the exponent on the bottom brought up to the numerator will go to negative power, minus 7x to the negative first for the same reason, plus 3x minus 11. As I apply the power rule, I'll take negative 3 times 2, which will produce negative 6, x to the negative 3 minus 1, which is negative 4. In a similar way, I move to the second term. Negative 1 times negative 7 is positive 7. X to the negative second, because it's negative 1 minus 1. And as we take a derivative of 3x, it takes us just to 3. And finally, when you take a derivative of a constant, we know that that drops out. As I look at this derivative notation, I notice that I still have these negative exponents. Generally, it's not acceptable to leave the exponents negative, so I will drop them back down to the denominator position. And then from there, sometimes we leave it like this. Other times we want to go ahead and take it a step farther. As we take it a step farther, what we look for is a common denominator. So the first term would be our common denominator because we have the x to the fourth. That means the second term I'd have to multiply top and bottom by x squared. And that produces 7x squared over the common denominator of x to the fourth. And for the third term, we'd have to multiply top and bottom by x to the fourth. That's why this becomes 3x to the fourth over x to the fourth. And there's our derivative.